All right, good afternoon. It is 5 p.m., January the 29th, the last live learning sessions of January. Got some things we got to get done tonight. I want to go through all of elasticity for sure. And if we have time at the end, I may move on to the next unit. I know I'm ahead of most of you guys. There's a couple of people that are with me right now. That's understandable. You're not supposed to rush to catch up with me. You got your own pace plan, follow your pace plan. But I want to make sure that I can be ahead or with the people that are going through the course a little bit faster. So, if you are watching this now, hopefully it's right before you do your elasticity unit, ELA. If not, you haven't got to it yet, you may want to wait and do this before you start the unit, or in the middle of the unit, however you want to do it. It will help you then, not so much if you're still doing some of the earlier stuff here. So just looking in here, it looks like I need a haircut. So I need to get a haircut. Hey, do me a favor. When you watch this video, send me an email right now. Just send me a quick email and say yes or no whether or not you think I need to get a haircut. I feel like I'm starting to get kind of like, big long hair here. So send me an email, yes or no, whether or not you think I should get my haircut. But here we go. Let's get started. Let me go ahead and shut off my video. As I say every time, I shut it off because they tell us to do so because some people in some counties have limited bandwidth, and my video takes away some of their bandwidth. So I shut it off. Not that I'm being bashful and don't want you to see me on camera. So, all right, so here we go. Let's get this party started here. I'm going to go and share my screen here and get it started. I'm trying to make sure that I am recording. Give me just a second here. I'm going to make sure I'm recording here. Yep, I am. Okay, sorry about that. All right, getting going. So today I'm going to do elasticity. I'm going to go ahead and start, even though I covered part of it the other day, I'm going to go ahead and start at the beginning of this unit with elasticity. So if you watched the last one, I apologize, but maybe you'll hear some things I might say a little bit different today. But the bottom line is elasticity is it's to measure the magnitude or how big percent change is brought about by a percent change in price. Okay, or how percent change in income or percent change in the price of related goods. We'll come back in just a second here. So the bottom line is we know that when price goes down, the quantity demanded goes up. We know that for a fact. It's called the law of demand. It's why the demand curve is downward sloping. Okay, when you have a downward demand curve, downward sloping like this, when the price goes down, we go this way, we're going to go that way, right? Because we're moving along this demand curve. Okay, so we know that's going to happen, but the question is how big is this percent change in quantity demanded? And that's what elasticity tells us. It tells us how big it is. Big change, it's elastic. Not a big change, it's called inelastic. And I went through and I said, what about if there's a price decrease by 1% and you have a 4% change in quantity demanded? We would say this is elastic because the percent change here in quantity demanded is bigger than the percent change in price. Right. And then I did another one and I said, okay, what if a 1% change in price leads to a 0.5% change in quantity demanded? We would say this is what we call inelastic. Inelastic. I don't know how to spell. Inelastic. There we go. It's called inelastic, right? Not elastic. You can't say not elastic. You have to use the term inelastic. They're going to expect you to use the correct terminology when you're referring to this thing. Okay. Then I told you there's this formula you have to know. There's actually 4 elasticity formulas, but if you learn the first one, the other 3 are very easy. Okay, so the formula is the percent. Okay, if you're doing the elasticity of demand is the percent change, delta's change in economics, in quantity demanded over the percent change in price. And this is what this is saying here. Okay, it's just I wrote it out in comments here. So then the question is, how do you do percent change? To do percent change, you always do the difference in the two divided by the original. The difference in the two divided by the original. Always divide by the original. That's the key. Always divide by the original. I'm about to show you this thing here. Okay, so how do we apply this thing here? Again, let me hit this real quick. Some places teach the midpoint formula to do this. If you're doing that, that's great. But then you've got to know this formula also. You have to know my formula, which is percent change, quantity demand over percent change in price. And you also have to know the midpoint formula. If you learn the midpoint formula, if you do mine, then you can do just mine. So I only always teach one formula, and that's the one I'm showing you here. When you're doing elasticity of demand, which is the, again, percent change in quantity demanded over the percent change in price, anytime you do that, you're always going to get a negative number. Say, if that's the case, if you always get a negative, ignore the negatives. Okay. And the reason is because price and quantity are going in opposite directions. Okay. And since price and quantity, since the quantity demand and the price are going in opposite directions, you'll always get a negative number. So ignore it. Okay. So what we're going to see here is I've got this linear demand curve. But since you're dealing with percent change, we're not doing slope. Slope is rise over run. The slope stays the same. We're not doing slope. We're doing elasticity of demand. Okay. But elasticity, and remember, EK is this, it's called essential knowledge. EK stands for essential knowledge. This is from the College Board. The College Board says this is the essential knowledge you should know here. The elasticity varies along the demand curve, meaning the slope is not elasticity. You're not doing the slope here. What I'm going to do is I'm going to go ahead and calculate the elasticity of demand for a price range. I don't remember what I did last time. I'm going to go ahead and do it from $7 to $6. I don't think I did that last time. No, I don't do 7 because it starts at 0. I think I did 6 to 5. We'll do from 5 to 4. Okay, I'm going to start off at a price of $5. I'm going to go down to a price of $4. And I want to calculate the elasticity coefficient of that range right there. Okay, well, the way to do that is you do elasticity of demand. If this said calculate, if the question says calculate, please keep this in mind when you're doing these problems for me in this class and for the AP exam. When it says calculate, you have to show, let me write this out. When it says calculate, the first thing you have to do is show the formula. So this one here is elasticity of demand is equal to percent change in quantity demanded over percent change in price. Second thing you have to do is plug in all the numbers. And then the third thing you have to do is give the answer. If it says calculate as the verb, and you don't do all three of these, you will not get credit on the test or the AP exam. Okay, you have to write the formula. You have to plug in all the numbers. You have to give the answer. I've graded an elasticity question many times at the AP reading, and that's what it always is and always will be, and I have to do it. So what we're going to do here is we're going to do this. So the first thing we do, again, is we're going to do the elasticity demand is we're going to do, because it says calculated percent change in quantity demanded, because we're doing elasticity demand over the percent change in price. Okay, grading this, I said this last week, but I'm going to say it again. Grading this in the past, one of the biggest mistakes students make is they flip this over. They do last percent change in price and percent change in quantity demanded. And the reason why they do that, I know why they do it. They see it is because price is read off this axis. So they do this divided by this. And that's not the case. It's always got to be percent change in quantity demanded over percent change in price. And I tell my students quarter pounder, quarter pounder, quarter pounder, quantity over price, percent change in quantity over percent change in price. Okay, so then we got to do the next thing they do is they misread it. They don't read it right. We starting at $5. I've told you that the price. The question I'm asking is we're moving from $5 here to $4 here. Oops, I'm gonna do that different color to $4 here. Okay, so to do that, we do percent change in quantity. So it's 4 minus 5. We're starting here at 4 minus, oh, that's a 6. 4 minus 6. 4 minus 6. 4, oops, boogers. 4 minus 6. And here's the key, divided by the original. It's always the change, 4 minus 6, divided by the original, 4. 4 minus 6 divided by 4, because you started at 4. I had a quantity of 4. You started at a quantity of 4. So it's 4 minus 6 divided by 4. Okay? This percent change of quantity. divided by percent change in price, which is 5 minus 4 divided by 5. You started at 5 and you went to 4, so it's 5 minus 4 divided by 5. Okay, and when you do this, you're going to get 2/4 divided by 1/5. Okay, use your calculator. You're allowed to use a calculator on the AP exam now. Use your calculator to figure out the answer. And what we're going to end up getting here is we're going to get 10/4, okay, which is roughly what, 2.5, 2.5. So the elasticity coefficient between a price of $5, $4 is 2.5. Okay, so what does 2.5 tell us? Okay, the 2.5 tells us that a 1% change in price led to a 2.5% change in quantity demanded. That's what the 2.5, when you calculated this guy right here, this 2.5, it's saying that a 1% change in price led to a 2.5% change in quantity demand. And you go, but there wasn't a 1% change in price. There was actually a 1/5% change in price. You're right. We ignore that because that's not what that's what we're doing here. The math is we're trying to figure out what is the 1% and it's 2.5. What does that mean? Elastic. Because if a 1% change in price leads to a 2.5% change in quantity, that's the percent change in quantity is bigger than the percent change in price, then we say it is elastic. Okay, let's go further down this curve here. And let's go, where am I? Okay, up, too far. Okay, and just by the way, just when we're reading, sorry, I'm using my fingers here. When we're reading this, more than one is always elastic, less than one is inelastic, and if it is one, it's called unitary or unit elastic. And since here we got 2.5, then it's elastic. If we kept on sliding down this curve, okay, if we kept on sliding down this curve, say, let's go from 2 to 1. So I'm going to start off at a price of $2, and I'm going to drop the price to $1. Let's calculate elasticity coefficient there. So elasticity demand is the percent change in quantity over the percent change in price. Percent change in quantity, we started at 10, went to 12, divided by the original. Okay, it's the difference in the two, from 10 minus 12 divided by the original, 10. So 10 minus 12 divided by 12, divided by now the percent change in price. Started at 2, 2 minus 1 divided by the original, which is 2. So it's going to be 2/10 divided by 1/2, which is going to be 4/10, which is 2/5. 2/5. What does that 2/5 mean? Okay, well, that 2/5 means that a 1% change in price led to a 2/5% change in quantity demanded, meaning inelastic. And what you'll find on these curves is that everything on the lower half of the curve, okay, everything down here is always going to be inelastic. And everything up here is always going to be elastic. And in fact, the midpoint of the formula, the midpoint, I'm sorry, not the midpoint of the line right here, the midpoint is going to be what we call unitary or unit elastic. You can either call it unitary or unit elastic, either unit elastic or unitary. Some books will call it one, some will call it the other. And that's where the elasticity demand coefficient you calculate is equal to 1, meaning a 1% change in price led to a 1% change in quantity demanded, unit elastic. And that will always be at the midpoint of the formula. I'm sorry, of the line, of the demand curve. Memorize this. You're going to use it numerous times in the test where they're going to ask about elasticity. And, it's going to, we're building into something here. We're building into something that you're going to need to know a little bit later on. But that's how you calculate elasticity of demand. Percent change in quantity over percent change in price. Memorize that the upper left-hand corner is elastic, the lower right-hand corner is inelastic, the midpoint is unitary, but also know how to calculate it because they may give you a scenario where you actually do have to calculate. Okay. Again, if it says calculate, you've got to show the formula, show all the numbers used and show the answer, and then if you don't do, and then show the answer. If you don't do all three steps, you will lose the point. So when I was calculating here, notice I did the formula, I plugged in all the numbers, and then I gave an answer. Over here, I showed the formula, I plugged in all the numbers, and then I gave an answer. I know you're allowed to use a calculator, but if you just give, say, negative 2 point or 2.5, you ignore the negative. You just said 2/5 here, you would not get credit. Doesn't matter, it's the right answer. You have to show the formula, plug in all the numbers, and that's what I'm going to be expecting in this course. All right. I put here calculate between 4 and 3 and 2 to 1. So if you want to practice, go ahead and do that. I'm not going to pause the video and do it because I've already done it for you here, a lot of it. But if you want to practice these just to see, make sure you can do it right here. That's the answer. So if you want to go ahead and do it from 4 to 3, sorry, I forgot I did this because I did put this together about 4 weeks ago. So if you want to go from 4 to 3, okay, I'll give you the answer in about 10, 15 seconds. And then if you want to do from 2 to 1, which I just did, I'll give you the answer. So pause the video, do it on your own. 5, 4, 3, 2, 1. Here's the answers. Okay, so from 4 to 3, that's percent change in quantity. Oops, no, that's percent change in price. You should have gotten negative 1.34, and of course you ignore the negative, so it's 1.34. Okay, and right here you should have gotten 0.4. Yeah, so I did. Okay, moving on. If the elasticity gives a percent change, okay, this I've already went in, that a 4% change in prices, a 2% change in quantity demanded, inelastic, 4% change in prices, 8% change in quantity, elastic, and if they're the same, inelastic. I'm sorry, unitary. They're the same. If the percent change in quantity, if the percent change in quantity demanded is equal to the percent change in price, then it's going to be unitary elastic. Okay. Probably they're going to ask you about something called the total. They're going to give you information, and you're going to have to use what's called the total revenue test to determine elasticity. So let's start with that because we're going to be getting into revenue here pretty soon here. Total revenue is the total amount of money that's coming into the cash register when they sell a product, and it's simply price times quantity. So if I have a pizza, Pet Mickey's Pizza Palace, okay, it's the pizza place I'm going to open up, Pet Mickey's Pizza Palace, and I sell 10 pizzas in an hour, and I sell them each for $10. I'll do a different thing. Let's say I sell them each for $9. I sell them all for $9. Then my price is $9. My quantity is 10. My total revenue is $90. I brought $90 into my cash register. Okay. But based on a downward sloping demand curve, if I'm selling these pizzas here and the price is $9 and I'm selling 10 pizzas, let's say I want to sell more pizza. If I want to sell more pizza, given the demand for my pizza, I have to lower my price. And if I lower my price to, say, $8, and I then sell 12 pizzas, then my total revenue is now going to be 8 times 12. It's going to be $8 times 12, which is 92. Is that right? 80, no, wait. Shoot, should have done this in the time. Wait, I'm gonna grab my calculator because we're all these calculators now. 8 times 12. I don't know my $96 is $96. Okay, I don't know my multiplication table by 12. You can probably learn that when you're younger, and you probably still remember it, but I don't. So $96. So what happened was I lowered my price, but yet my total revenue went up. Okay, why? how can it be possible? How can it be that when I lower my price, my total revenue went up? And the answer is that the percent change in quantity is greater than the percent change in price. Okay. And if that's the case, then I must have been in the elastic portion of the demand curve, which means this is not to scale. Okay. Because remember, the elastic portion has to be up here and the inelastic has to be down here. And the unitary point has to be in the middle. So that means my midpoint has to be somewhere after that. If that range right there is elasticity, and if I actually did the formula, if I did percent change in quantity, 10 minus 12 divided by 10, divided by 9 minus 8 divided by 9, I would get an equation greater than 1. Okay. But what I'm telling you here is that we can use what's called the total revenue test to figure this out also. All right. And here's the way the total revenue test works. Okay. Let me go and do that. Okay. What I always tell students to remember total revenue. No, let me show it to you first. Let me show it to you first, and then I was debating with myself what I'm going to do. So let me show you the total revenue test. All right. So what we're going to do is we're going to, on the top axis here, the top curve, and so I'm going to, and by the way, this set of graphs that I'm about to show you, on one exam, 1 year, I counted 7 multiple choice questions that, knowing what I'm about to show you, helped you either answer the question or eliminate wrong answers. So this is a huge concept. Pay attention to it, learn it, know how to do this, and know how to draw this when I'm drawing it to you, because it will help you answer questions on the AP exams. Guaranteed. Okay. So what we've got here is we've got a downward sloping demand curve. Okay. And you haven't learned this yet, but later on, we're gonna then put in something called a marginal revenue. Okay. In this class, marginal means change or additional, the additional revenue. And I'm just going to draw it for you now. Later on, we'll learn this a lot more, but if you learn it now a little bit, you'll be good to go. Out rats. Did a terrible job drawing that. Okay. So a marginal revenue curve looks like this. Okay. The marginal revenue is the additional revenue. Right. And by the way, you guys that remember this, you're probably thinking, wait, this looks familiar. Yes, all this stuff is so repetitive in this course that if you get one concept, it comes up later on. Remember earlier in very first unit, basic economic concepts, we did this thing called marginal utility. Utility is additional satisfaction. And we said, due to the law of diminishing marginal utility, as you consume a greater portion of a good, your additional satisfaction will decrease and it can actually go negative. Okay. This is the exact same concept, but we're dealing with revenue here, marginal revenue instead of marginal utility. Okay. And I'm going to go ahead and draw this for you and show this to you. And you're going to have to just kind of trust me that this is true. Okay. If we did the math behind it, if we sat here and spent, half an hour of your time of me doing the math to prove this to you, it would be true. Okay. If you don't believe me, you can go back and do this thing here. But the bottom line is, when marginal revenue right here hits 0, right there, that is the midpoint of a linear demand curve. And what do we know about the elasticity of a midpoint? That's the point that is unitary elastic. Everything above this is elastic, and everything below this is inelastic. So right off the bat, a multiple choice question they can ask about: when marginal revenue is positive, you're in the elastic portion of the demand curve. When marginal revenue is negative, you're in the inelastic portion of the demand curve. When marginal revenue is equal to 0, you're at the unitary portion of the demand curve. And I can tell you guys, this is a huge concept. And you don't know why right now. You're saying, well, okay, great, Pat McGee, it's a huge concept. You don't know why, but this is going to come into play a little bit later on when we start talking about monopolies and where monopolies choose to produce, how many units they should sell. Perfect competitor, how many units they sell. This is going to become, it's all going to come back to this sort of concept here. So make sure you get this now. Okay, understand you got your downward slope demand curve. You have a marginal revenue curve that falls faster, at a steeper rate than the demand curve. And when MR is 0, you're at the unitary point on your demand curve. Anytime marginal revenue here is positive, you're in the elastic portion of the demand curve. Anytime it's negative, you're in the inelastic portion of the demand curve. And again, we know that because if we go back to way back here, when we did this, we said everything up here is elastic and everything down here is inelastic. You just have to know that. We calculated it. Elastic. Okay. We calculated it to prove it. We did the math throughout here to prove that, this is greater than 1 and down here is less than 1. So we did the math to prove it. Midpoint is unitary, right? But what I'm telling you now, if I were to draw a MR curve here, this MR curve would go through, let's say that's exactly the midpoint point. I don't know what that is. Let's say it is, though. I'd have to do the math real quick. See, this would be the MR curve. Okay. So that's a linear, it's going to be a linear MR curve. And remember, in this class, no rulers are allowed, so you have to get used to drawing your stuff. I'm not really good at it because I'm writing with a pen on a little bitty computer screen. I'm much better on a big smart board or with my on pen and paper. Okay, so I still hadn't gotten to this whole thing I'm trying to show you, which is the total revenue test. Okay, so the next thing we got to do here is we got to go ahead and put what is the relationship between marginal revenue and total revenue. Okay. When we did marginal utility way back earlier, we did marginal utility and we did total utility. And I told you, let's say you have one piece of pizza and it's really, really good and it gives you 15 additional units of satisfaction. That means you have a total satisfaction of 15 units. And remember, utility is the measure of satisfaction. It's fictitious, but oh man, it was so good. That gave me 15 utils, right? We don't know what your scale is. Maybe 15 is the highest. Maybe 100 is your highest and 15 isn't really that great, but still it gave you 15 units of satisfaction. So I'm just making up numbers here. Okay. Due to the fact of law of diminishing marginal utility, if you have a second piece of pizza, your satisfaction might drop to 12 additional units of satisfaction. Well, you got 15 out of the first, and now you're getting 12 more. When you add these two together, you end up getting a total of 27 units of total utility. Let's say you keep on consuming and the third one gives you 5, you're up to 32 because 15 here, 15 plus 12 plus 5 is 32. And let's say you have the fourth piece of pizza and it gives you a -1 utils of satisfaction. You eat it and you're like, oh gosh, I'm so sick. Why did I eat that last piece of pizza? It wasn't even good. Why did I eat it? By the way, why wasn't it good? Because of the law of diminishing marginal utility. It's the same pizza that you've been eating. You just had a fourth piece, right? So what happens is your total utility now begins to go down. It's still positive. Notice the total utility is still positive, but it's starting to go down. Okay, that's the concepts between marginal utility and total utility. We have the exact same thing here with marginal revenue and total revenue. And the idea is that as long as marginal is positive, okay, it's above this horizontal axis. Remember, this point right here is 0, 0. As long as it's above this horizontal axis, when marginal is positive, what's total got to be doing? Okay, when marginal is positive here, total is going up. As soon as marginal goes negative, total goes down, right? And so when we draw this guy here, if we want to put price there, I got this way. I'm going to draw a new one real quick here, just make it work because this is not big enough together. Downward slope in demand, MR falls at a faster rate. And down here, and by the way, this is price and also marginal revenue. I'm going to just draw total revenue. And what I'm going to find out is that right here, when marginal is 0, total is at its maximum. So that's your total revenue curve. When marginal is positive in this green area right here, total is going to be going up. When marginal goes negative, what color is it? I'll use yellow. When marginal goes negative, total is going down. Okay. If you know this, now we can talk about elasticities because we know that at this point right here, that's the unitary point. And down here is inelastic, and up here is elastic. So what I'm going to do now is I'm going to lower my price. I'm going to start way up here, right here, at this price right here, and I'm going to lower it. This is really getting messy. I'm going to lower it to here. I'm going to lower it to here. So I lowered my price. What happened to total revenue? Total revenue went from here, there's my total revenue, to here. Notice my total revenue went up. So in the elastic portion of the demand curve up here, upper left-hand corner, okay, in the elastic portion up here, when price goes down, total revenue goes up. If I do the same thing, I'm not going to waste the time doing it right now, but I promise you, if I do the same thing here, when price goes down, total revenue is going to go down. In other words, they go in the same direction in the inelastic portion of the demand curve. So in the elastic portion of the demand curve, when price goes up, when price goes down, total revenue goes up. And if when price goes up, total revenue is going to go down. In other words, they move in opposite directions. In the inelastic portion of the demand curve, when price goes up, so try again. When price goes down, total revenue goes down. And when price goes up, total revenue goes up. In other words, they move in the same direction. Okay. Now, I have a memory device for this. If you're actually taking the AP exam and they ask you a question, you can't just use my memory device. If it's a multiple choice, then they don't know how you got it. But this is for multiple choice, not for a free response question. But what I do is I pull out a rubber band. Okay. And a rubber band, a fancy name for a rubber band, is also an elastic band. And you take that rubber band and you look at it, and the top part of that rubber band is price, and the bottom part of that rubber band is total revenue. And what happens is when you raise the top part, when you lift up the, I'm going to turn my camera for this. I want y'all to see this. Okay, I don't have a rubber band, but I probably should have had one. Okay, well, the camera's on. Let me see if I've got one here. Having, I'm so sorry, guys. I should have had one, but I didn't really think base didn't want it. Since I'm in it, I'm gonna do it. All right. So imagine I've got a rubber band. Okay, I've got a rubber band. This is the top part is the price, bottom part is total revenue. And what happens is when I raise the price, total revenue can go down. So in other words, they go in opposite directions. They can go in opposite directions because this elastic band, okay, rubber band's called elastic. This elastic band can go in opposite directions, which is exactly what this formula is. Formula is it shows you that when price goes up, total revenue goes down. What about the other way? If price goes down, total revenue goes up. So they can go in opposite directions. And when it's elastic, price and total revenue go in opposite directions. Okay. What if I had a paper clip? Okay. A paper clip, a gem clip. What if I have a gem clip? Okay. Gem clips are not elastic. Okay. Gem clips are not elastic. So if we put price at the top and total revenue in the bottom, when price goes up, total revenue has to go up. When price goes down, total revenue has to go down. They have to move in the same direction. So price and total revenue move in the same direction when it's inelastic, not elastic. When it's elastic rubber band, they move in opposite directions. Okay, so that's a way to not have to sit here and draw this all out to figure out what's going on. It saves you time there. And this is what we call the total revenue test. The total revenue test is if demand is elastic, if you decrease price, what's going to happen to total revenue? It's going to increase because it's elastic. They go in opposite direction. When you decrease price, total revenue increases. If you increase price, total revenue decreases, right? And so you can just figure this out. What's going to happen to your total revenue? Okay, now think about this. Think about a firm. Wouldn't a firm want to know what happens to its total revenue, right? And by the way, I told you wrong earlier, didn't I? Look at there. Here, I decreased the price and total revenue went up. That's opposite direction. That's elastic. Okay, never mind. I said it right. So, all right, moving on. If demand is elastic, a change in price will result in a change in total revenue opposite direction. If demand is inelastic, a change in price will leave total revenue in the same direction. If it's unitary, then you get no change in total revenue. So in other words, if we change the price, there's no change in total revenue. Then it's unit elastic or unitary elastic. Okay, so if you understand the concept, you can you may have to draw this graph, and I guarantee you're going to be drawing this top graph. Guarantee it. You're going to be drawing the top graph. Then you may have to figure out stuff with the bottom graph. On the AP exam, it has been asked a couple times. So, all right, let's move on. All right, boy, I'm taking a lot of time on this. Okay, so when you move along a curve, you can calculate the elasticity of demand, or we call that elasticity coefficient. Okay, when you move along a curve. But we also, just to confuse you, because a lot of times in economics, we make up stuff just to confuse students, and so not really, but just to confuse you, we're also going to refer to curves themselves as being elastic or inelastic. Okay, and most of the time, when you draw a curve in this class, and you draw a demand curve, you go price, vertical axis, quantity, horizontal axis. You draw your demand curve, and you draw it about 45-degree line. You draw it at about 45 degrees. But occasionally the question will say, given an elastic demand curve, or given an inelastic demand curve. If that's the case, you have to draw the curve not at a 45-degree line, but at a different angle. An elastic demand curve is one where the percent change in price leads to a bigger percent. So if we change price just a little bit, it leads to a bigger percent change in quantity. That would be a flatter demand curve. Okay, an inelastic demand curve is where a change in price leads to an almost no change in quantity, and that would be a steeper demand curve. Okay, these are all basically, when we say a curve is elastic, we're talking about relatively. We're talking about relative to what most demand curves, how we draw most demand curves. It looks like this. Most demand curves are just like a 45-degree line. When they're flatter like this, it's elastic. When they're steeper like this, it's inelastic. Okay, because if you did the math here, when you change the price here, you're not going to get much of a change in quantity. And right here, when you change the price, you're going to get a big change in quantity if you did the math on these things, guys. So elastic is flatter. And I tell students you can remember this, because when you do an elastic demand curve like that, if I do a really elastic demand curve, let's do one really elastic. If I do one really elastic like this looks more like the E, like an E. When you do an inelastic demand curve like this, it looks more like an I. That's a D, inelastic. Okay, so it looks more like an I, and this one here looks more like an E. That's elastic. Okay, elastic, inelastic. Okay, so why? Why do our curves, some of them elastic and some of them are inelastic? Here's the 4 reasons. I'm going to go through these very, very quickly, but I'm going to give you some examples. First is luxury versus necessity. If you have to have it and they raise the price, what do? You buy it anyways. That's inelastic. You're not going to respond to the change in price. If they lower the price and you have to have it, okay? Well, if it's just a necessity that you use, like toilet paper, okay? Toilet paper, when they lower the price in toilet paper, do you use more toilet paper? No, you don't. You don't use more toilet paper. It's a necessity. If you got to have it, you buy about the same amount of toilet paper. Now, barring the fact I buy, like my wife and I, when it's on sale, we buy a bunch and throw it in our pantry, so not our pantry, or some closet somewhere, so we can save it for later on. That's a different thing, but that's the most part. If it's a luxury and they raise the price, you stop buying it. There's a huge percent change in quantity when they raise the price on a luxury. So what you've got is a luxury is going to be more elastic, and a necessity is going to be more inelastic. The more necessary it is, the more inelastic the demand curve. Insulin for a diabetic has a very inelastic or steep demand curve. Okay. Availability of substitutes. Well, if I can replace it with something else and they raise the price, then I won't buy it. So the more substitutes, the more elastic, the more they respond to a change in price. Price goes up, quantity demand, it goes way down if there's lots of substitutes. If there's no substitutes, again, like insulin, there's no substitute for insulin for somebody who's diabetic. When they raise the price, They have to use it anyways. So you got double whammy right now on something like insulin. It's a necessity, and there are no substitutes, right? Um, Toilet paper, it's a necessity, and there are really no substitutes. I mean, I guess you can use leaves or tree bark or something like that, but that wouldn't be very comfortable, right? Necessity, inelastic, no substitutes, inelastic. Next, these next two are not quite as important. Okay, the first two are the ones they usually always test, but let's run over the next two real quick. The next is proportion of income. The bottom line is the more expensive it is, the more elastic it becomes. The more expensive, if you have a $100,000 house, okay, and I increase the price by 10%. This $100,000 house is now $110,000. That's going to chase away a lot of people. If I have a 10-cent piece of bubble gum and I raise the price by 10%, now it goes to 11 cents. It's not going to chase away very many people. Okay. So the more expensive something is, the bigger the change in quantity demand. And in other words, the more elastic. The less expensive it is, the less people respond to, oh no, it's now 11 cents. Ooh, you're still going to buy less. Law of demand says you'll buy a lesser quantity demanded, right? The quantity demand will decrease. But are you really going to like, oh, I'm going to buy a whole bunch less? No, that 1 cent is not really going to blow anybody away. So the more expensive, more elastic, less expensive, more inelastic. And the last one is time. If you have to have it right now, if you have to have it right now, it basically becomes, oh, shoot, I went the wrong way. If you have to have it right now, it basically becomes a necessity. Okay. Tires. If you blow a tire in your car, you go to a tire store, you're like, oh man, I got to have it now. And you're willing to pay the price, even though it's expensive. If you know your tires are getting bad and you've got time to start shopping, then you can wait for them to go on sale. Okay, so it becomes more elastic. You can wait for the change in price. So it becomes more elastic. The more time, more elastic. Okay, understand these four, know how they work. Let me move on. Okay, next. We're going to get these rare cases where you have something that is perfectly inelastic or perfectly elastic. Please, folks, you only use this when it says perfectly or completely or totally. If they say it's inelastic, if I tell you something is a demand curve is inelastic, I am telling you it is a steeper demand curve. If I'm telling you it's perfectly inelastic, then the demand curve would be vertical. That would be a perfectly inelastic demand curve, meaning the quantity does not change no matter what the price. This would be something like medicine. I go into the heart surgeon and he says, "Oh man, I'm so glad you're here because you're not going to make it till tomorrow without open heart surgery." And he says, and it's too bad because tomorrow it's going to go on sale, but we have to do it right now. What am I going to do? Wait till tomorrow? Right? Now, in reality, nothing really is perfectly inelastic. Somebody might take the chance. Well, I'm going to take the chance till tomorrow because I can't afford to, be price it is today, right? But we like to play that some things are perfectly inelastic. Okay, that the quantity does not change when the price changes. The opposite of that is perfectly elastic, and we're going to do a lot of that in this class, where you have a perfectly elastic demand curve, which means that basically at this price, there's going to be this massive number of quantities that could be bought or would be bought at that price. And we're going to explain this later on in we get into perfect competition and what this means and why we use this guy in this course. But that'd be perfectly elastic. Again, most of the time we draw them that are 45 degrees. All right, let me run through. I got about 16 more minutes. We'll run through the other elasticities. The next is elasticity of supply. This is going to measure the responsiveness in quantity supplied, okay, the quantity supplied to the change in price. We know that supply curves are always upward sloping, all right? And because of that, we're always going to get a positive number. Ignore the positive, okay? It is the exact same formula as elasticity of demand, but we're going to do it with the supply curve instead of the demand curve. So it's percent change in quantity supplied over percent change in price. You do the exact same thing. I told you, you have to know the formula, percent change in quantity over percent change in price. But here it's exact percent change quantity demanded, elasticity of demand, versus percent change quantity supplied, elasticity of supply. So you calculate it, you're going to get the exact same interpretation. Less than one is inelastic, and I'll tell you the inelastic portion is always down here. The elastic portion is always up here. And technically somewhere there's a unitary elastic point. Okay, so it works the exact same way, the exact same formula, but you're doing percent change of quantity supplied, percent change of quantity demanded. Boom, you got it. I don't ask it very often on the test, but just in case they do, you can do it. Just know the one formula, percent change of quantity or percent change of price. Just plug in what you're changing here. Which brings us to the next formula. Oh, the elasticity of supply depends on substitutes and time also. Availability of substitutes, this is substitute resources. Like for example, if workers, there's no substitute for a worker, then the supply curve is going to be very inelastic. But if there's lots of substitutes, maybe I can replace workers with machines, and there's lots of different types of machines that can do this job, then that supply curve becomes more elastic or flatter. So anyways, next, cross elasticity demand. Okay, cross elasticity demand. What we're doing here is we're going to change the price of one product, and it's going to affect the demand or the quantity demanded for the other. Okay, we did this back at the very beginning in demand, price of a substitute, price of a complement. And that's what this is. We're dealing with the price of a substitute or a price of a complement. The formula is the exact same one, percent change in quantity demanded of one product divided by the percent change in price of another. Here, you do not ignore the negatives. The negatives are very important. Okay, and you need to know the negatives. Okay, I'm going to tell you right now, because I've got it written here, and it's the only way I know it, is that if it's a positive number, they're substitutes. If it's a negative number, then they're complements. Okay, you have to know that. But I don't have it memorized. I've been teaching this class since 1996. I majored in economics in college. I've been dealing with economics for 50 years of my life here. Not 50, but anyways, a long time. And I don't have this memorized, but I can always figure it out. And anytime anybody asks me a question, substitute or complement, I just do this. I take two products that I know are either substitutes or complements. Let's take peanut butter and jelly. Okay, for most people, peanut butter and jelly are complementary goods. If it's not for you, then pick a different example. Let's do peanut butter and jelly. So what I'm going to do is I'm going to go ahead and change this real quick. I know this formula because I have to know the formula anyways. This is peanut butter and this is jelly. And I find out that when you raise the price of jelly, people go shop and they go, oh no, jelly's peanut butter. One is on the bottom, sorry. Sorry about that. That's got all choked up thinking about this example. So right here, when you raise the price of peanut butter, people go shopping. They go, oh no, peanut butter is more expensive. So they stop buying peanut butter, right? But what do they also do? They stop buying jelly. A negative over a positive is a negative number. So that means negative numbers must be, since peanut butter and jelly are complements, must be complementary. Is that true? Yay, negatives complement. I got it right. Yay, right? Let's do two different examples here. Let's find one that is a substitute. Okay, let's do beef and chicken. Okay, if you are vegetarian, you don't consume either one of those or one of those, I apologize, but that's most people beef and chicken. Okay, so let's go ahead and do beef down here, and let's do chicken up here. Let's go shopping and let's lower the price of beef. And it doesn't matter if you raise it or lower it, you're still going to try to get the same answer. If you lower the price of beef, people go shopping and they go, oh, hey, beef's on sale. They buy a lot more beef. That means they are not going to buy chicken. Negative over negative is a positive number. So is positive substitutes. Yes, beef and chicken are substitutes. Yay, I got it right. Memorize the formula, know how to apply it, and you don't have to worry about memorizing that that's a positive substitutes and negative complements. You don't have to memorize this crap. Figure it out every time. Just do it. You know the formula anyways. You're gonna have to know the formula. You have to know the formula. Okay, don't waste your time memorizing this stuff. All right, last one is income elasticity. Income elasticity is going to tell us whether or not a good is a normal good or an inferior good. Okay, if your income goes up and you buy more of it, that's a normal good. If your income goes down, you buy less of it. That's also a normal good. Notice both of these are positive numbers. So that means positive must be somewhere I've got it in here. A normal good must be a positive. I don't have it here. There. Yeah, positive is normal, right? If your income goes up and you buy less of it, that's an inferior good. Negative number, negative numbers must be inferior. Same formula, by the way, is percent change in quantity demanded, but instead of percent change in quantity of price, and I didn't tell you the formula if I did this, instead of percent change in quantity demanded over percent change in price, it's percent change in quantity demanded over percent change in income. It's called the income elasticity demand. So you got four formulas, okay? There's elasticity of demand, which is the percent change in quantity over the percent change in price, quarter pounder. This is quantity demanded. There's elasticity of supply, which is the percent change, which is the percent change in quantity supplied over the percent change in price. There's income elasticity, elasticity income, which is the percent change in quantity demanded over percent change in income, because income elasticity. And then there's cross price elasticity. It's the percent change in quantity demanded of one good, say X, over the percent change in quantity demanded of another good, say Y. And I did X and Y, so I did here. Four formulas, but all the same one. Learn one, you got it down. You're going to have to do it on the AP exam. Guarantee probably 2 or 3 different questions. Okay, I have 8 minutes. I'm going to start this. I won't finish it, but I'm going to go ahead and show it. I don't think I'll finish it. Okay, governments, as we know, use taxes and subsidies to change people's incentives, to get you to do something, to change your behavior, to get you to buy more or less of things. And when taxes are applied to a product, it changes the supply of the good. One of the determinants of supply is taxes. Okay, you've already learned that. If you did when you did the SAD unit, supply and demand unit, you learned that taxes is a determinant of supply. So let me show you what this looks like. So what we've got right here in this market, the current at this equilibrium point right here, we've got our upward slope of supply, our downward slope of demand. Axes is labeled P and Q. We have an equilibrium price of $12 and equilibrium quantity of 100. What we're going to do now is we're going to come in and we're going to put in a $2 tax on this product. The government puts in a $2 tax. The way you show taxes is you show it with a vertical shift. We always say the supply curve shifts left, but it actually does shift up by $2. So the way I've drawn it is this then is going to shift from 10 to 12. At 80 units here, it's going to go from 11 to 13. And at 100 units, it's going to go from 12 up to 14. So this is going to be the supply with the tax. And the tax is a $2 shift. So anywhere, and this is huge, once you know this, we can deal with the rest of this. The vertical distance here between 12 and 10 is 2. Between 13 and 11 is 2. And between 12 and this would be 14 up here. I want up here, this would be 14, is 2. That vertical distance is $12. Now, we just put a $12 tax on this product. I'm sorry, we just put a $2 tax on this product, so it's shifted up by $2. Okay. Now, how does that affect us? This is the key here. Okay. Right now, people are in the news right now, tariffs. Tariffs are in the news big time. Okay. And the erroneous assumption by the American people and by the media and by everybody else is that the other guys are going to pay the tax. That's not true. The tax is going to be split. Your prices will go up when there's a tariff. That's just the way tariffs work. Taxes. A tax is a fancy name. A tariff is a tariff. A tariff is a tax on other countries' goods coming into our country, but it's a tax. All right. So how does it affect us here? Okay. The idea is that businesses don't absorb all the tax. They're going to attempt to pass as much of this on as they can. So the tax is before, the way you have to look at this is before the tax, the price was $12. We paid 12 and the producer received $12. per unit. So we pay 12, they receive 12. Soon as the tax is put on, the supply curve shifts to the left, we now pay 13. And this is, by the way, only works this way because I have this nice 45-degree line. Next week, when I start this, I'm not going to show you 45-degree lines. I'll show you what happens when the elasticity is not perfectly 45 degrees. But we're paying $13. How much is the tax? Well, the tax is at $2, but yet we're paying only $1 more. And in fact, this area right here is our portion of the tax. Okay, that's the consumer's portion of the tax, because before we were paying 12, now we're paying 13. Before we were getting 100 units, now we're only buying 80 units because we don't want it as bad because of the higher price, right? So this area right here is the consumer portion of the tax. We're paying $1 of the $2 tax. What about the seller? Before, the seller was receiving 12. Now they're collecting 13, but they have to send $2 to the government, so they only get to keep 11. So this portion down here is their share of the tax. They're, in this case, also paying $1. They're also paying $1 of this tax. So what happened in this case is the tax, the $2 tax, was split evenly. They paid $1, we paid $1. And by the way, just to finish this out real quick, our consumer surplus is now only this, and their producer surplus is now only this. Okay, where before the consumer surplus was that, remember that, right? And the producer surplus was that. So we both lost surplus here, and our good friend deadweight loss is back. That's loss of consumer producer surplus. So the tax reduces consumer surplus, it reduces producer surplus, it reduces consumer surplus. Yeah, I already said that. It reduces both surpluses. Okay. Anyways, I said that, and it creates deadweight loss. So this is the producer's portion of the tax. So taxes are not split evenly unless it's a 45-degree line. Supply and demand just happen to be perfectly 45-degree. Taxes are not borne by one or the other unless, as I'll show you later on, if we had a perfectly elastic demand curve or a perfectly inelastic demand curve, then tax would not be passed on to others. What it really comes down to is how necessary is the product. Okay, if you think about it, if you have to have a product and a tax is put on it, who's going to pay most of the tax? The one who is necessary for, the buyer. If you don't have to have it and they put a tax on it, then you're like, I'm not paying that tax. Then the other guy, the seller, has to pay it, right? And so it really just comes down to how necessary the product is. And it goes back to what we learned here. We learned back here, way back here, about the different things that tells us the elasticity of the product. Luxury versus necessity, availability substitutes, proportion of income, and time. And so if we put a tax on a product that's a luxury with lots of substitutes, that is a low proportion of income, and we don't have to have it right now, then the seller is going to pay the vast majority of the tax. If we put a tax on a product that's a necessity, not many substitutes, a high proportion of our income, and we got to have it now, then we're going to pay most of the tax, right? And so that's the idea here that's going to come in. It's called tax incidence. It's who's paying the tax. Okay, and I'll pick this up again next week. I'll probably review this here. I'm gonna go with the deadweight loss. I'm gonna show you this here again. Okay, and then I'm gonna go into it. I'm gonna show you what happens when we change the slopes of the demand curve, who pays the tax. So next week I'm gonna do that, and I'll actually start the next unit, which is getting into perfect competition and cost curves and things like that. So have a great evening. Enjoy, or I guess it may not be evening when you're watching this video, I don't know, but email if you have any questions.